You can have 10 to any power, to any exponent in scientific notation, but in our base 10 system, we often group special powers of 10. We usually think in terms of thousands, millions, and billions, etc. 1,000 is 10 times 10 times 10, so that's 10 to the 3. 1 million is 10 to the 6. 100th is 1 divided by 100, or 10 to the negative 2. 1,000th would be 10 to the negative 3, etc. And so we have unit prefixes in the metric system that give us special names and special symbols that we can use to replace these common powers of 10 that we will see. And that allows us to group our numbers in expected ways. And also using a unit prefix here rolls off the tongue a little bit more easily than writing out or explaining, saying out the entire power of 10 for scientific notation. So this is a way to further simplify scientific notation, particularly in a presentation when you're trying to describe or say these values, or in a scientific report when you want to keep the numbers compact so that they don't distract your reader. The scientific notation is easier when you're doing calculations, and the unit prefixes are easier when you're trying to express yourself in words. So to use unit prefixes, we start out with a number, any number that we want, and we convert it to scientific notation, just like we saw how to do. So here we have 4,600 joules. These are our significant figures, and I have 4.6 times 10 to the 3 joules. That is correct. This is mathematically a very simple way to express this, but 4.6 times 10 to the 3 joules doesn't exactly roll off the tongue. It's a little bit of a tongue twister. So what we can do instead is say, well, 10 to the 3 has a special symbol and name for it. 10 to the 3 is called kilo, and I can use a lowercase k to represent that 10 to the 3. So I can remove this 10 to the 3 and put a lowercase k there instead. And so I can express this same number as 4.6 kilojoules. And that rolls off the tongue. It's much easier to say. It's much more compact if I'm writing it in a report. This value is still easier to use if you are plugging into your calculator. We can do the same thing with this number. I have 5.30 times 10 to the negative 6 seconds, but 10 to the negative 6 has its own unit prefix. This is micro, and it uses a Greek letter mu. It looks something like an M, but it's different. It is a mu. And so I can replace this 10 to the negative 6 with a mu symbol there, and I can call this 5.30 microseconds. And again, it's a more compact way of saying it or writing it. The power of 10 does not always perfectly align with the special prefixes. These special prefixes go up in groups of 3, so sometimes you'll have a value that doesn't quite work like that. For example, here, if we put this in scientific notation, this would be 7.5 times 10 to the 4 seconds. And so 10 to the 4 is not one of our special powers of 10. What we can do is break this up. 10 to the 4 means 10 times 10 times 10 times 10, 10 multiplied together 4 times. So I can group that as 10 times 10 to the 3 instead. This is still 10 to the 4, because it's 10 times 10 times 10 times 10. Now this 10 to the 3 is kilo. This 10 is by itself, so I'm going to group it back with the 7.5. And 10 times 7.5 is 75. And my K symbol for kilo, seconds. I can also just look directly at the number. I know that I'm moving my decimal to the left, so I'm going to be multiplying by 10. I can move it 3 places to the left to get me to kilo, and I can see that I'd have 75 in that case, 75 kiloseconds. The same thing here if I have a very small number. I have 1.3 times 10 to the negative 4 watts. 10 to the negative 4 is also not one of my powers of 10, so I could break that up and make that times 10 to the negative 1 times 10 to the negative 3. 10 to the negative 3 is milli. And now I have a spare 10 to the negative 1. 10 to the negative 1, remember, means we are dividing by 10. And so 1.3 divided by 10 would be 0.13 milliwatts. I can go the other way with this as well. 10 to the negative 4 is smaller than 10 to the negative 3. It's bigger than 10 to the negative 6. So I could go either way with these values if I wanted to. For example, if I'm moving my decimal place 1, 2, 3, 4 places to get 10 to the negative 4, I could also move it 5, 6 places to get to 10 to the negative 6. That would give me a decimal point here, which would give me 130. And then 6 decimal places would be micro. I would use mu here, 130 microwatts, which still gives me the proper number of significant figures. I could do the same thing up here. I could move my decimal place 6 places here and have it here. Implicitly, there'd be a 0 there. And I could call that 0.075. 10 to the 6 would be megaseconds. So it depends. I usually prefer to use the value that gives me a number bigger than 1. This is bigger than 1, this is less than 1, this is bigger than 1, this is less than 1, because you're either, if you fall between two values, you can go to the higher value or go to the lower value. Sometimes, depending on the industry you're in or what other units you're using, sometimes you always default to one particular value. For example, you always use megajoules or gigajoules or something like that in a power system. A couple special cases here. These unit prefixes are always built on top of the standard units. So we've talked about standard units of meters and seconds. And so we would tack these on top of those standard units. We've seen watts are units for power. We've seen joules are units for energy. We can tack these prefixes on top of those as well. One special case is the kilogram. The kilogram is considered the base unit in the SI system, even though kilo means that a kilogram is already 1,000 grams. And so that's one thing that can be kind of confusing, but keep that in mind. Also, when you are given values using these unit prefixes, it's best to convert them back to their corresponding powers of 10 before you begin calculations. For example, if you are working on a problem where you have a value given to you as an energy that is 10 kilojoules, just go ahead and write that as 10 times 10 to the 3 joules, right? You are converting the kilo back to 10 to the 3. And then when you plug into your calculator, you'll plug into your calculator in full scientific notation so that your calculator can interpret those numbers and give you the proper outcome. Finally, there are many metric prefixes. We go from 10 to the 24 all the way to 10 to the negative 24. Because our units, for example, our unit for meter is about a yard long, but meters are supposed to measure everything from the distances between galaxies down to the distances between protons in an atomic nucleus. So we have quite a range. Be aware that these exist, and you can look these up if you need them. But in general, what we will need to know for this class are these ones here and these ones here. These are the ones that you'll use most often, and you should be familiar with those.